So now let's talk about three factors that affect pulmonary ventilation. So what affects pulmonary ventilation? Well, first, obviously, is the resistance of the airways. Okay, so here's the question. Do you think, like, is it easy to move air? Come on, like, it's pretty easy, right? So generally speaking, resistance is low. Unless you have a lot of mucus, unless you have severe constriction, we can neglect the resistance. You see what I'm saying? So basically two things that can increase the resistance is accumulation of mucus as the result of inflammation or cystic fibrosis, and constriction of the airways, like in anaphylactic shock. We clear? Second thing. Surfactant. Surface tension. So, your lungs, listen up, your lungs is not a bag. Are you following me? They consist of many pockets, very small, almost circular pockets, called alveoli. Are you with me? So when we say that lung inflates, like those lungs, the big lungs that we had here, when they inflate, they aren't inflating like a bag. Each individual alveolus gets inflated, and the whole lung gets inflated too. Are we clear? Now, imagine that this is an alveolus. The surface of the alveoli from the inside, they covered with fluid. Water-based fluid. So far so good? So individual molecules of water, they get attracted to each other. Okay, you see that? They try to stick together. When you try to make this alveolus bigger, look, these molecules of water have to be positioned farther from one another. Look at this. Think of it this way. You have to spread the same number of water molecules over a greater area. Does it make sense? And you really can't. I mean, you can, but you have to go against the cohesion of water, the attraction of water molecules to each other. You see what I'm saying? Basically, you can think of it this way. It's like inflating a balloon. The bigger the balloon, the harder it is to inflate it farther. Am I making sense? It's really easy to go from this to this, but it's much harder to go from this to this because it's already superinflated. So anything that reduces the water, the surface tension within the alveolus is great. And this is the role of surfactant, surface active compound. It's basically a composition of proteins, right? A whole bunch of proteins that reduce the surface tension. I usually give this example. Did you make soap bubbles when you were a kid? Okay, let me ask. So imagine you have a glass of tea, water, doesn't matter, and you have a straw, and you start bubbling air through water. Are they going to be bubbles? Of course. Are they going to be stable? No. Now what you do, you add a couple of drops of dishwasher or dish detergent, mix it well in that water, and start bubbling again. What you're going to end up with? A lot of foam, right? Does it make sense? So what happens? Your bubbles without detergent, due to the surface tension, collapse. When you add detergent, they don't. They remain kind of inflated. Make sense? So surfactant is really important. It is normally produced, but for instance in newborns that were born preterm, like really preterm, lungs are not fully developed and they do not produce enough surfactant. Are you following me? Which means that due to the increased surface tension every time they exhale, every time the lungs deflate, they not just deflate, they collapse. This is why the preterm babies, they have to have mechanical ventilation to help them breathe before they fully develop. And you know what's the catch here, kind of catch-22? Let me ask you this. When we normally breathe, the flow of air into the lungs, I don't know how to ask it better, but is it forced or not? When we're inhaling, is it forced or is it just kind of going downhill? Well, think of it this way. It's simply pressure here is higher than there. Does that make sense? So the air, like, very easily flows into the lungs. Are you following me? When you have a mechanical ventilation, air is actively pumped into it. And this active pumping creates mechanical injury to the lungs. And this is something that, people who are on the mechanical ventilation have to face consequences of. They are going to have some mild mechanical injury to the lungs because of the pumping nature. This is what happened. The paradox was that we eliminated polio and we got rid of iron lungs. And when COVID happened, a lot of physicians said it would be much better to put a patient into an iron lung and let it flow normally, you see, than to stuff their lungs with air through the ventilator because of such a traumatic nature of it. That makes sense? Okay. Lastly, the third factor here is lung compliance. This is basically an ability of a lung to inflate and deflate. Let me ask you this. What is easier to inflate? A balloon or a car tire? Why? Why balloon is easier than car tire? Tire is what? Thicker, yeah, that's it. So if a patient has scar tissue in the lung, like scar tissue here, scar tissue in the alveoli, right? Scar tissue in the alveoli. Patient has it. Scar tissue is not elastic. Does that make sense? It's not. So, scar tissue results in the lower lung compliance. And generally speaking, lower lung compliance means that it's harder to inflate. And look, conversely, higher compliance means that it's easier to inflate. And the opposite, like you can say that in people with lower lung compliance, lungs are harder to inflate, but easier to deflate. They more readily deflate. Does that make sense? Questions here?
How
This.
do you get scar tissue on your lungs?
Why?
No, like how?
Oh, yeah. Infection, like pleuritis, inflammation of pleura. There are some genetic disorders that result not so much in the scar tissue, but in, so the walls of alveoli, there's a lot of elastic connective tissue around here. There are genetic disorders that make it less elastic. That's it. Like, poor bastard, you're like born with it, you know, unfortunately. You see what I'm saying? But mostly the damage to the scar tissue comes from inflammation, pleuritis. Okay, I would bet that emphysema, well, emphysema is a separate story. There's a lot of stuff going on in emphysema. But part of it is that the walls of the lung harden and become harder to inflate. Questions?
Did you say if they're harder, or if they're harder to inflate, they would also be harder to deflate?
No, easier.
Easier to
Yeah, think of it, I mean, it's not essential, it's not directly relatable to car tires, but they're less elastic, so they're more likely to like collapse immediately. Then more elastic, that would take more time to go back. That makes sense?